Now we are going to do the graph of exponential function and log function. So let's see the packet, the day 9. We'll go there. Okay, 9.1, graph of exponential and log functions. So we learned already, so that the inverse function of exponential function is what? Log function, right? So exponential and log function, they are inverse function each other. So we learned how to get the inverse function from the exponential function. So let's see the example. So we have a y equal to 2 to the x power. So how do you find the inverse function? First, what do? Y becomes x becomes y. Then x equal to 2 to the y power. So this is the inverse function of this one. Inverse function means reflection over y equals x line here, right? You reflect over this one, the graph must be like this. But when you have a function, you should write down the function y equal the rest. But now y is in the power. So how do we change this one into the standard form? So you should put the y down, right, from the power. So how do you change it? So when you put the power down, we use log function. So easy thing is, you should know the base of exponential function becomes same base in the log function. So 2 goes to the base here for log, and then x go to the parentheses. Oh, so y equal 2 to the x and y equals log 2x, they are inverse functions. So how do you draw the graph? Exponential function, we should know the graph never touch x-axis, right? It looks like the graph touches here, but actually it doesn't touch. It goes close, 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 but never touches. That we call horizontal asymptote. But in the log function, because it's inverse function, x becomes y, y becomes x. So horizontal asymptote, which is y equal to 0 line, becomes now vertical asymptote in the log function, which is x equal to 0. The vertical asymptote is what? X equal to 0 here. And in this exponential function, here, y-intercept is 1, right? Then in the log function, instead of y-intercept, we have x-intercept, which is 1. And you can go to the, again, the what? Meta calculator, right? So when you put, especially when you put the log function, we learned how to put into the fractions. So let's try this one together in the meta calculator. So I'll see the equation, and log 2x, the base goes down, and in the fraction, the rest goes up. So log x in the numerator divided by the base is log 2, right? 2 in the parentheses. And then if you enter, look at this. So now, if you see this, the graph looks like touch the y-axis, but actually it doesn't touch. It goes close, 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 and keep going down to the negative infinity, but never touch. Just remember, so we should remember log function has vertical asymptote, right? So like this, you have a few examples. Please find out inverse function of this exponential function and draw the graph for uh, exponential function and log function. So, and when you draw the graph for log function, especially log function, you don't need to first go to the table and find the only integer coordinates, right? Let's see the table first. Create the table. If you see, oh, it's from the 20, but let's go to the 0. And 0 is negative infinity, but something wrong. It's not negative infinity, but it doesn't exist actually. It's error. It should be error. And when x is 1, y is 0. When x is 2, y is 1. This integer coordinate, you plot these points on the plane, but you don't need to do these, decimals. And next one is x4, y is 2. And when x is 8, y is 3. I think that's good enough. And make sure you put the arrows in both ends. And then you are done. Your graph will be like this. All right, then I will stop here so you can do the other problems by yourself.